Okay, we are recording this lesson and we're looking at question 5. And my screen is visible to you, right? Okay, thank you. Right, we're looking at question 5.1. Okay, these questions will be done in pretty much a random order. I have combined my questions with yours because the papers were squashed, so they did not look tidy to me. And so I've scanned and brought in like newer what? Newer questions. So just obviously we have some easy reading. For instance, we're gonna look at question 5. In a survey of 1530 skydivers were asked if they had a broken limb. Okay, the results of the survey were as follows. The male ones with a broken limb were 463. Not a broken limb were B. The total was 782, and so on. Now, the question 5.1 says calculate the values of A, B, C, and D. Let's find the value of A, for example. Right, so the value of A will clearly become the total minus the males. The males. Right, so what is the total? Right, so the total is 900 and what? 913. This one, that is the total. Minus the males. The males are 463. And what is the answer? The answer is exactly 450. So in other words, it means that the value of A is 450. We need to find the value of B in this two-way table. Or now let's find the value of B. So the value of B, you can see B occurs in this row of the males, but it occurs also in the row of the females, this one. So note, therefore, that we can use any of the columns here. We can use either the first column or the second column. So I'm going to use, we can you either use the first row or the second column. So I'm going to use the first row because it has only one unknown B. 463 we know, B we don't know, 782 we know. So we're going to say B is the total. Total minus 463, in other words, minus the number with, right, so it will be 463 minus the, you can just say 463 minus broken a limb. 463 minus broken a limb. Number, okay? So what is the total number there? All right. So we can see the total number is exactly 782 minus broken a limb, which is 463. What is the total here? The total 782 minus 463, use a calculator. And if you use a calculator, what do we get? We get exactly what? 782 minus 463, we get 319. So that's what we get. So now you have C. Now we have C is this one. Now C is there. We can see C occurs in the column of the not broken a limb. So we can use that information. So for instance, we can say C is the total minus not broken a limb. Not broken a limb. Okay, these guys are skydivers. So the skydivers, they jump off airplanes. Now they break their limbs in the process. So not broken a limb number. What is the total for C? Right, for C, for instance, we can consider this column here. So the total is at the bottom is actually 617 minus not broken a limb. Not broken a limb of the males. Not broken a limb, males. So now, the males not broken a limb, we saw the B. What did we get B to be? We got B to be 319. So in other words, what is 617 minus 319? It is exactly 298. Okay, we continue and we look at D as well. We need to find D as well, and D is sitting there. So D can be found in a couple of ways. One way to find D is to consider this row and you add A and C. So somebody can say, okay, D is exactly A plus C. So, okay, it's risky because if A and C are incorrect, then D is going to be incorrect. But we have two ways to find D. So A is 450 and C is what? Is 298. We have already found this. What is 450 plus 298? It's exactly 748. Right, so next we have D, which is 1530 minus 782. What is 1530 minus 782? It is also 748. So that gives us like another way of finding the D here. Right, so we have found the numerical values of A, B, C, and D. Okay, any question? No question. Right, so we're looking at 5.2. Calculate the probability of choosing at random in the survey a female skydiver who has not broken a limb. Female skydiver who has not broken a limb. Okay, we have lady skydivers, female ones, who have not broken a limb. So we look at 5.2. Right, so we look at 5.2. Calculate the probability of choosing at random in the survey a female skydiver who has not broken a limb. Right, so at this point, we need to think about this. So the probability, we need to find the probability. So the probability of a female skydiver, female who has not broken a limb. Broken a limb. Okay, so what is the probability of this? What is the probability of the female? The female not broken a limb, you can see the female not broken a limb. Not broken a limb, female is C. Over the total is this one, 1530. So what is the probability of the female? For C, we've already got. We got C to be 298. We divide that by 1530. And therefore, we get the result. What is the result? The result is 149 divided by what? By 765. We can simplify this like that. Next, we can use a calculator to find the decimal equivalents. The two decimal places or more. So this is 0.195, three decimal places. Well, that's what I chose. Okay, but yeah, you can round it off to approximately 0.20. It's the same thing. Right, so that is the probability of choosing at random in the survey a female skydiver who has not broken a limb. Right, not broken a limb and is female. C, over the total. Okay, two-way tables, just have the skill to read them in probability theory. Now in 5.3, is being a female, okay, is being a female skydiver having broken a limb independent? Female skydiver having broken a limb independent? Use calculations corrected to decimal places to motivate your answer. 5.3. All right, now we're going to look at two things here. All right, so we're going to consider the fact that we have the following. Right. So we have the probability of female and broken a limb. Right, so female and broken a limb. All right, so what is the probability of female and broken a limb? What is the probability of female and broken a limb? Right, so the probability of female and broken a limb is what? So think about this. Right, so we have already got the rest of these here. Right, so broken limb is this one and female is this one. Right, so we have already got A. What did we get A to be? We got A to be 450. 450. So you come here and you put female and broken limb is 450 divided by the total. Is the total. The total is 1530. 1530. Here it is. And then now we're going to use the calculator. Well, we can just simplify this. You divide through, and it simplifies to 5 over 17. Using a calculator, you can get the result and say 0.294 76 471. All right, and this is approximately 0.29. Okay, these are the questions you sent to me. So obviously I was looking at what in 5.3 they asked us, or are they independent or not? So we investigate. All right. Next, we're gonna look at this. The next thing we're gonna look at is if you look at the probability of female multiplied by the probability of a broken limb. What is the probability of female? The probability of female is what? Right, so the probability of female, now let me just plug in the values we got here. Okay, we got the values here. Let me just plug them in to the table so that we can see very well, because we can forget. Lest we forget. So A is 450. What is B? B is 319. What is C? It is 298. Okay, we got them. So I'm just picking them from where we work them out. Okay, D is 748. So what is the probability of female? The probability of the female is what? Right, female. The probability of female, you take the total for the female, which is 748. So you have 748. You divide by the total. The total is 1530. Multiplied by the broken limb. Broken limb. Right. So the probability of broken limb, what is the total of broken limb? Total of broken limb is 913. We divide by the total. What is the total? It's 1530. Okay. We go on to simplify this. So this is approximately 0.29. Good news. So we can see something. What do we see? We're able to see that the probability is 0.29 there and 0.29 there. So the probabilities are the same. So we have the same probability. So the events are independent. So the two events are independent. And this becomes the conclusion. We say the events of being female and having broken a limb are independent. The events of being female and having broken a limb are independent. So they ask the question, is being a female skydiver and having broken a limb independent? Well, the answer is yes. Yes. Yes, comma, the events of being female and having broken a limb are independent. And the conclusion, obviously, is that with the independent events, I want to bring to attention that you have the probability of this. The probability of female and broken a limb. Therefore, the probability of female and broken a limb, it is the same as the probability of female multiplied by the probability of broken a limb. Broken a limb. The probability of female and broken a limb is the probability of female times broken a limb. And this is independence of the events. This means if these events are independent. Okay. You think about your questions, etc., and we can address the questions. Right, let's look at the next question from the questions you sent to me. We're looking at 3.1. Question 3. Right, so in 3.1 now we're saying A and B are mutually exclusive events such that the probability of A is this and the probability of not B is that. Show that the probability of B is 2. Very easy. All right, so we say that the probability of that, so we know that the probability of B is equal to 1 minus the probability of not B. So the probability of B equals 1 minus, what is the probability of not B? 0.58. So the probability of B is 1 minus 0.58. What is the answer? Okay, so it is exactly 0.42. Right, so note therefore that this is the result we're getting. So which means therefore the probability of this is that one. Right, so the probability of the probability of B is 0.42, as the examiner wanted us to prove or to show. Right, so the next thing is to look at 3.1.2. Determine the probability of A and the probability of B, the probability of A and B. So the probability of A and B, what is this probability? The probability of A and B, what is this probability? Well, the probability of A and B in this case is going to be equal to 0. Why? Because A and B are mutually exclusive events. So if two events are mutually exclusive, then the probability of A and B is equal to 0. Alternatively, we write like this and say the probability of A intersection B is identically 0 for mutually exclusive events. All right. Now we look at the next question, 3.1.3. Determine the probability of A or B. So we're looking at 3.1.3. We're looking at 3.1.3. Right, so 3.1.3, we have the probability of A or B. So the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So what is this? This is the probability of A or B, which is the probability of A. What is the probability of A here? Okay, this is the formula. The probability of A or B is written like that, okay? Is the probability of A plus the probability of B minus the probability of A and B. This formula is normally at the back of the exam paper. That's part of the formula sheet. Now, the probability of A is there in the question. What is the probability of A? It's 0.25. So the probability of A is 0.25 plus. What is the probability of B? We've already got the probability of B is 0.42. Okay, we got it there. The probability of A and B, this event are mutually exclusive and the probability is 0. And therefore, this means the probability of A or B is the summation. What is the summation? 0.25 plus 0.42 is actually 0.67. So the probability of A or B is 0.67. Right, so we're happy. So we have done that question, finding the probability of A or B. For 3 marks, draw a Venn diagram to represent the probabilities. Let's just draw a Venn diagram. Right, so a Venn diagram is there in 3.1.4. Right, here is a Venn diagram. So the Venn diagram must be what actually, first and foremost, a sample space, what I call the universal set. The sample space with the events inside. So in other words, you have this one here, which will have the probability of A, and then you have the probability of B. So this one is the probability of A, the probability of B. Look at this. The probability of A here is what? Is 0.25. Okay. And then the probability of B is 0.42. We've already got in the previous question. And obviously, we've already got the probability of B, which is 0.42. And then we have that the probability inside must be 1. Everything must be 1. So in the event that the probability, these two events not occur, you have that the probability outside is going to be 1 minus 0.25 minus 0.42. In other words, we have 1 minus the probability of A minus the probability of B. Okay, and this result is what? It is if you subtract everything here, you get 0.33. So this one is 0.33. So in other words, to draw a Venn diagram to represent the probabilities, and this is what you get. So 1 mark is for a probability of A because the marks are 4. 1 mark is for a probability of A. 1 mark is for a probability of B. 1 mark is for the complement of those. And obviously, and just 1 mark for the setup there. Okay, and showing your sample space. Okay, right. So in 3.1.5, you need to determine the probability of not A or B. Determine the probability of not A or B. Let's look at 3.1.5. Right, so that one in 3.1.5, the probability of that. So you have the probability of not A or B, which is what? Okay, the probability of not A or B is the probability of not A plus the probability of, so we're using this formula, this one. I mean, I'm going to encircle this one in what? In green. So the probability of not A or B is exactly that one. Is the probability of A plus the probability of B minus the probability of A and B. So we use the same thing. So the probability of not A is actually the same as the probability of not A plus the probability of what? The probability of B. Let me write properly. And let me use the red color here. The probability of B. And then we subtract the probability of not A and what? And B. And B. So what is the probability of not A? Right, the probability of not A is 1 minus the probability of A. The probability of B is there. We're going to substitute this one. And then now we have minus the probability of not A. Okay, so this one can be done in many ways. Probability of not A and B. So what is 1 minus the probability of A? Which is 1 minus 0.25, because the probability of A is 0.25. What is the probability of B? We've already seen in 3.1.1 is 0.42. What is the probability of not A and B? Not A and B. So let's look at this one. So you can just make use of the Venn diagram thing. Because if you look at the probability of not A and B, and you can do this in many ways. You can maybe also just, right. So the probability of not A and B. Right. So now you're going to look at what happens if you say not A. So the probability of not A here, so you are looking at what is happening outside A and B. Right. So if you say not A, so you're looking at what is happening outside A, and it must intersect B. So it is just the probability of B, and which is 0.42. So B is just 0.42. So if you have to look at probability of not A and B, is just 0.42. So which means, therefore, we are in business, right? So now we just need to do the calculation here and say 1 minus 0.25 plus 0.42 minus 0.42. Okay, it's easy. 0.75. 0.75. Okay, because it's 0.42 and 0.42 cancel out. So now the probability is here is 0.75. So that's like the probability of not A or B. Not A or B. So there are a couple of ways to do this. It can be directly done with ease from the Venn diagram. Okay, because now, if you look at the Venn diagram like this, if you look at the Venn diagram like this, put here probability of A, put here probability of B. Okay, we are in business now. And okay, I'm just repeating the Venn diagram. We know it already. Right, so you have the sample space. The probability of A is 0.25, that of B is 0.42. So this is a sample space. So this is 0.25, 0.42, 0.33. And then now we have this. This is a sample space. So if they ask you to find the probability of the following, okay, the examiner asks you to find the probability of not A or B. Okay, the probability of not A or B. Right, so which means the probability of not A or B. So what is the probability of not A? So not A, you are going outside A or B. Right, so not A or B. So in other words, you are taking the probability of 0.33 plus 0.42 and you're adding them up. What is the answer? So 0.33 plus 0.42 and the result is 0.75. Hey, which is exactly what we got here. It's exactly what we got. Right, so that's what you can get. So we are doing probability calculations. Now, the next thing now is what we did. The first question, we've already found the probability of the values of the A, B, C, and D. So we've already done a 3.2.1. We've already done 3.2.2 to calculate the probability of choosing at random in the survey a female skydiver who has not broken a limb. So that one, choosing if in the survey a female skydiver who has not broken a limb, it was 5.2. So we've already done that one. Obviously, this question is the one we need to just do now. Suppose that only male skydivers are considered, and when you can do that, what do we know? Well, furthermore, right? When you can do that, you'll have to say, okay, you can do this. Then what more? You suppose that only male skydivers are considered, calculate the probability of choosing at random in the survey if male skydiver with a broken limb. Good. Let's look at 3.2.3. Right, so this one is pretty Very straightforward. Very, very straightforward. So now you continue and you say the probability of, in 3.2.3, the probability of a male diver, a male skydiver, right, male skydivers, of choosing at random in the survey, male skydiver with a broken limb. Right, so male skydiver with a broken limb. At this point, you suppose that only male skydivers are considered. Only male skydivers are considered. So do not consider the females. So we're only considering these here. We're only considering these. And we think we just cross out all the females. We just say the females are not there. So in the total, you cross out this one. Right. So, which means the probability of a skydiver looking at only males and who has with a broken limb. Broken limb. So that's going to be 463 divided by 782. So the probability of a male diver with a broken limb. Right. So a probability of a male skydiver with a broken limb. So it is 463 divided by 782. And then we're able to get the result. Right, so if we do that, this is the answer, but we can, right, we can look at it further. Right, so you can take this one and use your calculator to get the decimal equivalence, but not quite necessary. Sometimes you can leave your answer in this form. Right, because what we're having is we're having 463. It is divided by 782. Okay, because we're looking at only males here. And now that will be approximately 0.59207, approximately 0.59. All right. Goodness me. Is being a female skydiver having broken a limb independent? We used independent. For independence in 3.2.4, we are looking at the probability of F means female, stands for female, and having broken a limb, B would mean broken a limb. Broken a limb. Okay, so it means the probability of female and broken a limb is the probability of female times the probability of broken a limb. So this kind of a mathematical relation is actually called the, if this is true, we have independent events. Independent what? We have independent events. If it happens that this relation, this formula holds true, all right, so we are in business. We continue and we solve more probability questions. Let's look at the next question. Right, this next question is question 10, and question 10 is very interesting. It looks at another Venn diagram with three events, A, B, and C. And let's just go through the question together. Question 10. Right, so this question is a very, very interesting question. And we spend time on it because it is most certainly nice and sweet. Nice, nice and sweet. Research was conducted. Research was what? In question 10, was conducted about driving under the influence of alcohol. The information obtained from the traffic authorities in 54 countries And all the methods that are used to measure alcohol levels in a person are summarized below. Traffic authorities in 54 countries. It's like the whole of Africa. Okay, in Africa we have about 54 countries. Just a comment there. Okay, so we have about 54 countries in Africa. We are a very good study case. We are a very good study basket case. So you can consider this and think about this as very, very essential. As a region of study. Okay, as a region of study. Now, 4 countries use all 3 methods, A, B, and C. Okay, so 4 countries use all 3 methods, A, B, and C. Right, so look at this. 4 countries use all 3 methods, A, B, and C. Right, they use A, B, and C. And those are 4 countries. Remember, I was speaking of 54 countries. Right, so 12 countries use the alcohol content of breath, blood alcohol, concentration B. So breath and blood alcohol concentration B. So in other words, you have 12 countries that only use A and B. And those are 12 countries. But 4 countries use everything. So you can see there that the 4 countries are using every single bit of thing. Everything. But 12 countries use the alcohol content of breath A and blood alcohol concentration B. So they use the breath. They use those breathalyzers for the those traffic authorities. I'm sure you're aware of that. You have heard of that. Then they are actually to determine if somebody is drunk or not, or if they are under the influence of alcohol. 9 countries use blood alcohol concentration B and certificates issued by doctors C. Right, so 9 countries use blood concentration B and certificates used by doctors. So now you have that 9 countries use B and C. B and C. Those are exactly what? 9 countries. They use B and C. Right, so if there are to be 9, it means D is 5, because 5 plus 4 is 9. Right, so we can find some of the values as we go along, as we read this question. So because we need to know that we have 9 countries, so it means therefore D equals 5. Okay, we need to find some of the values here. Right, 8 countries use the alcohol content of breath A and certificates issued by doctors. Right, let's look at this one here. Right, so if we understand that 8 countries use the alcohol content of breath A and certificates issued by doctors C. Right, so, and those are 8 countries. So 8 countries use A and C. Let's look at A and C. Right, here is A and here is C. And those are how many countries? Those are exactly 8 countries. Right, so now what does it mean for us exactly? It then means that for A and C, then E must be 4, because those are 8 countries. So it therefore means that we have that E is 4, because 4 plus 4 is 8, and those are 8 countries. So which means that here E is equal to what? E is equal to 4. Next. Say we're analyzing this question. 21 countries use the alcohol content of breath. So 21, everything in B must be in A. Okay, 21 countries use the alcohol content of breath A. So in other words, it therefore means that everything in A must be 21. Right. So if everything in A must be 21, let's see what we're getting now. What can G be? Okay, let's see. What is 4 plus 4 plus 8? 4 plus 4 is 8, and 8 plus 8 is 16. So what can you get G to be? So we can get that G is exactly equal to what? G is exactly equal to 5 because you have 21. So we have that G is equal to 5. Okay. Next, we continue to analyze more mathematics. Right. Okay, so we continue. We continue. Let's see now. Right. Now, if you look at the 32 countries, use blood alcohol concentration B. Let's look at that. Okay, I'm trying to clean up this Venn diagram because otherwise then you can't see what we're doing. If it's so dirty, so untidy. Okay. So 32 countries use blood alcohol concentration B. Let's look at the 32 countries. Right, 32 countries use blood alcohol concentration B. Right, so now it means therefore the 32 countries, everything in B must be what? Must be 32. So what is this? What is 4 plus 8? 4 plus 8 is 12. 12 plus 15 is what? Is 27. So if it's 27, what do we add to 27 to get 32? We can add only 5. We have already got D anyway. We got it earlier. Okay, next. 20 countries use certificates issued by doctors. Those are 20 countries use certificates used by doctors, so that is going to give us F. And those are 20. So here we need 20. Right, if you need 20 here, but obviously E already got, we got E to be equal to 4 because this was 8. So now, which means that we have 8 plus F. Right, so now, let's see now. Everything in C must be 20. So 4 plus 4, the E, which is 4 and the other 4, 4 plus 4 is 8. And then 8 plus 5 is what? Is 13. So now that F can only be 7. So F is 7. Okay, now we continue. How far are we with this question? We're supposed to get D. We've already got. We're supposed to get E. We've already got. We're supposed to get G. We've already got. We're supposed to get F. We've already got. So we've got everything here. We just need to calculate the probabilities. Let's enjoy ourselves. Let's enjoy ourselves and find the probabilities here and have some fun. Have some great, great fun. And have great joy. Right. So for example, in 10 point, okay, for the purpose of your question, okay, your teacher asked you to find D, E, F, and G. But we can just do the probabilities as well, okay? Because I went to, I found this in my question bank of questions, so you can practice here. There's no harm. Your teacher did not ask you to continue. He had just asked you to find those, but yeah, we can do that. We have the time. We have the time with Nobile. Right, so now let's continue then there and find the probability of A and B and C. Right, so the probability of A and B and C, what is it? The probability, so we're looking at 10.1.2, A. The probability of A and B and C. What is the probability of A and B and C? Right, so the probability of every single bit of thing. So A and B and C, you're looking at everything where they all meet. Where do they all meet these things, these events? Where do they all meet? So we can see that they all meet here at 4. So which means the probability of A and B and C, the teacher did not ask you, but it will be 4 over the total of the 54 countries. And we can divide this one and rather simplify this to 8 out of 9. Okay, so it's 8 out of 9 in the first one. So we have 10.1.2b. The probability of A or B or C. The probability of A or B or C. Let's look at this one. So the probability of A or B or C, what is it? Let's think about this. Let's think about this. So now, this one will be the same as, so it will be obviously out of 54. Right, and then we remember this one is 4, we plug in the numbers. D we know is 5, F we know is 7, and G we know is 5 as well. And then now, if we are to find, therefore, the probability of A or B or C, right? So in other words, now we are gonna add everything inside. It's only this one that's outside. So it's 6 is 54. So we know that this must be 48. Everything must be 48. So which means, therefore, if we add everything, we get 48. So we have 48, right? So if you have 48 divided by 54, it is exactly 8 out of 9. So in other words, the probability of this is 8 out of 9 in 10.1.2. So we are done. This one here, 10.1.2 part B. Okay, next we enjoy our probability calculations there with Nobile. 10.1.2, but we're looking at part C, right? Only part C. Probability of only C. The probability of only C. What is the probability of only C? What is inside C? Right, what is inside C exactly? Only C will be the same as only C that has nothing to do with you cut this out, you cut everything out. Only C is exactly 7 out of 54. Only C is exactly 7 out of 54, and that is the probability of only C. Okay. Next, we're looking at 10.1.2. We're looking at part D. The probability that a country uses exactly 2 methods. Look at this one. The probability that a country uses exactly 2 methods. 2 methods. What is the probability of this? The probability that a country uses exactly what? Two methods. Okay, let's continue. Okay. All right. All right. So we have that. Okay. The probability of what? That a country uses exactly two methods. Let's analyze that one together. Right. Now we are looking at these. Yeah, this is making the whole thing untidy. But yeah, it's useful a little bit, obviously, when you analyze this. Probably that a country uses exactly two methods. Right. So the probability that a country uses exactly two methods is going to be out of 54 countries. Total number of the countries is 54. Right. That a country uses exactly two methods. So in other words, you'd have that either a country uses A and B or uses B and C, uses A and B, B and C, A and C, something of this sort. Okay, so it uses then two. Right. That the country uses exactly two methods. And then what is this? Right. So obviously we have this. What is the probability that a country uses for A and B? What is the how many countries are there in A and B? Right. So we can see therefore that we have those countries in for instance there's A and B, and then you have um, B and C, B and C. How many of those countries are there? Okay, we got some of these here. Okay, let me put them back. D was 5, E was 4, F was 7, and G was 5. So what is this thing? And what is the probability of this here? Yes, my dear? All right. Okay, so we continue with our calculation, and I'm here. All right, all right. We continue with our calculation. So the probability that the country uses exactly two methods, as said, either A and B or B and C, A and C. Okay, so that kind of thing. What is then the probability, rather, how many countries are those there in those intersections? So, right, let's see now. Okay, for instance, you have that the probability of B and C, or the countries in B and C, now you can see there are 5 of them, only B and C. And then now you can see that the countries, for instance, in A and C, or first let's say, yeah, A and C, A and C, A and C without B. So you'd have 4. And then you continue. And then the probability of one more, okay? If you look at, for instance, A and B excluding C, we have 8. And then if you add everything here, you're getting 17 out of 54. Right, you're getting 17 out of 54. So the probability that a country uses exactly 2 methods. Here you have, as said already, you have 84 A and B, and you exclude C. All right, so this is it. So the probability that a country uses exactly what? Exactly 2 methods. It's that one there. Okay. And then we are done with this question. So we're done with this question, but also, okay, we're done with this one. We're done with this one. We are done with this one. We are done with this one. Your teacher asked you this, so we got 100% there. Okay. So we are happy. We are the happy people. We got the 50 marks. Okay, we continue with the calculations. And also this one, we've already done above. This one, we've already done. Okay, let's just let's just do this one here. Let's just do question 1. All right, question 1 is a very interesting one and focuses on a couple of things. Question 1. Right, so question 1 focuses on a couple of things and we look at it together. We look at it together. Right, we're looking at question 1.1. The following table gives the frequency distribution of the what? Of the daily traveling time in minutes from home to work for the staff at a local shopping mall. Right, now the daily traveling, the midpoint of class interval, the frequency, no number of teachers. The frequency, which is the number of the teachers. Okay. Now we're dealing with the numbers of the teachers. But if you look at 1.1.1, calculate the estimated mean time. The estimated mean time. Right, so this one is straightforward, the estimated mean time, and we enjoy ourselves with more statistics and probability. Statistics and probability. Right, the estimated mean time, so we say the estimated mean time. What is the estimated mean time? Is the sum of fx divided by that. Sum of fx divided by n. So with need, then you can say the sum of fi xi divided by n. Right, so this n is actually the sum of the frequencies. Okay, what is this? Now, we do it together. Now you need to focus on the class midpoints. And you need to focus on the um, frequencies and you multiply everything. So here, this one is going to be 5 times 20, 15 times 36, 25 times 32, 35 times 8. Too congested, maybe? Let me space a little bit. 5 times 20, 15 times 36, 25 times 32, 25 times 32, then 35 times 8, and then 45 times 4. You divide everything by the total. So the total of the frequencies is 20 plus 36 plus 32 plus 8 plus 4. And then it's going to give us X bar. Right. So let's enjoy ourselves. First things first, we just learn the mathematics by saying we're 5 times 20 plus 15 times 36. 5 times 20 plus 15 times 36 plus 25 times what? 32 plus 35 times what? 8 plus 45 times 4. Okay, so it's like this is giving me 1900, 1900. You divide everything by, so you have 5 by 20, then you have 15 by 36, you have 25 by 32, you have 35 by 8, you have 45 by 4. And then you have 20 plus 36 plus 32 plus 8 plus 4. And what is the result? Okay, this is giving 100. So that X bar is obvious. It's exactly 19. So which means that X bar is 19. So this gives us an indication of the fact that the actual estimated mean time is exactly 19. Okay, so obviously this has to do with you using a calculator. This formula is the formula you need to learn, and you need to make sure that you can use this formula in the exams. I must warn you that this formula is also applicable in the matric syllabus. So being at grade 11 right now, you are already a step ahead because you already have your marks under the statistics section. So now in the stats section, statistics, you already have your marks. And then now you just have to um, um, just get to the matric class and sit in the class and collect your marks. And therefore, collecting your marks will give you the distinction you most certainly desire. Okay, so that is what we have. The estimated mean is 19. Now, in 1.1.2, calculate the estimated standard deviation for the data. Right, the estimated standard deviation is just very similar to this one. So there's a formula we use for this, and we shall learn these together. Okay, so let's look at the estimated standard deviation. So we're looking at 1.1.2. The estimated standard deviation, you can call it sigma, and then you write a square root like this. It is the summation of the Fi frequencies, and then you multiply by xi minus the x bar, and then you square the difference and you divide by n. And you can divide even by capital N there, like this. Right. There is a common practice, so you can do it exactly like that. Okay, you can do it exactly that way. So now, with this, then we are in business. We are certainly in business. We are certainly in business. We're certainly in business. So, which means that the sigma is the same as what? So, you're going to say sigma is the same as the square root. Right? The summation of the frequencies. So, the frequency here is going to be 20. You multiply by the xi minus x bar. So you have the xi, which is the midpoint of the class, minus the x bar, which is 19. You square this one. You add. And then now you have 36. 36, you can just put the brackets here. Okay, so let me write properly. So you can write the frequency 20, which is this one. And then you multiply by the class midpoint, which is 5, minus the mean. What is the mean? Is 19. And then you square these. Plus the frequency is 36 into the class midpoint is 15. It is 15, and then you subtract from it x bar 19. And then you square this. And then next you do the frequency. What is the frequency? The frequency is 32. Here you have taken 36. And then I can write at the bottom and write it here. So you have here the frequency is 32. And then you have the class midpoint, 25, 19. Next, you have this one, frequency. The frequency is 8, and then the midpoint. The midpoint is 35 minus 19, and then you square these. And then you have the frequency. It is 4 into the midpoint, 45, minus the average, x bar. You square these. Okay, so you have this. So here you have the square root like this. So all these things here will be divided by what? Will be divided by n, the sum of all these frequencies, and we've already got the frequencies. They became 100, everything. When we add all these, we got 100. So now we just need to do the top. We need to do the top with Nobile. Let's just do the top. So now doing the top, all right. So you continue. I'm using my calculator to do this one. So now, so with 20 into 5 minus 19, you square it, plus 36 into 15 minus 19, plus 32 into 25 minus 19, plus 8 into 35 minus 19, plus 4 into 45 minus 19. You square it. Right, so now if you say 20, right, it looks like it is the following. It looks like it is exactly 10,400. We divide by 100. Right, because if you say 20 into 5 minus 19, and then you have 36 into 15 minus 19, you have 32 into 25 minus 19, you have 8 into 35 minus 19, you have 4 into 45 minus 19. Right, so at the end of the day, you have 104. If you divide the 10,400 by 100, it becomes 104. And then you get the square root of 104. The square root of 104 can be seen as follows. Okay, it is exactly 4 times 26. It's exactly 4 times 26. And 4 times 26 can be seen as 2 into the square root of what? The square root of 26. And this is the estimated standard deviation. But this estimated standard deviation can be written as a decimal fraction. So it is 10 points. You can write the point, 2 decimal places, 3 decimal places, 19803. A bit more decimal places there. Okay, but obviously it's popular with the exams that normally you need to round your answers to 2 decimal places, or it's going to be approximately 20 there. Okay, so this is permissible. All right. Now we continue and we enjoy our statistics and probability up to solving the questions you sent to me. With the need, I will certainly make provision and also provide more questions because these questions do not look like they are a lot. Okay, let's look at 1.2. Right, an Ogive was constructed from the given data. Right, we have been given data and suddenly an Ogive was what? Was constructed. Suddenly an Ogive was constructed. Right, so let's continue with this. Okay, that's fine. All right, so let's continue. An Ogive was constructed from the given data, and this is the Ogive. They've already done it for us, so we are happy. But now they're saying construct because this is 1.2, and then we're looking at 1.2.1. Construct a box and whisker plot on the scaled axis below the Ogive. To summarize the data, show on the Ogive by means of dotted lines where you have read off the data required for the box and whisker plot. Use the diagram provided in the diagram sheet. Okay, let's look at this question. Okay, so obviously we're going to do it straight from here. We need to construct a box and whisker plot. So we're looking at question 1.2. So the box and whisker plot has two things, or it has four about. Okay, let's start. So it has Q1, it has Q2, and then there's Q3. So this one is a quarter of n, this one is 2/4 of n, and this one is 3/4 of n. So in each case, this one will be a quarter of the total frequency. A quarter of the total frequency. So what is the total frequency? All right, we added everything and we got 100. You can just confirm again here. If you add everything here, you get 100. Is it true? Okay, let's just check. So you have 20 plus 36 plus 32 plus 8 plus 4. You have 100. So which means that we have a quarter of 100. What is a quarter of 100? Is 25. Okay, these are just positions I'm dealing with here. Positions. So here you'd have 2/4 of 100. Okay, so 2/4 of 100 is going to give half of 100. Half of 100 is 50. 3/4 of 100. 3/4 of 100. So what is 100 divided by 4? So divide 100 by 4, you get 25 by 3, it's 75. This. So we continue. Right, so let's continue and answer the questions. So now, need to construct a box and whisker plot. On the scaled axis below the Ogive, below the Ogive curve, to summarize the data, show the Ogive by means of dotted lines, where you have read off the data required for the box and whisker. Use the diagram provided. Is the data positive, negatively skewed? You provide a reason for the answer. Okay. Now, let's look at this. What is the position of Q1? Right, the position of Q1 is like at 25 for the frequency. So in other words, you're gonna take 25 for the frequency. So where is 25 for the frequency? Right. So you realize a couple of things as a matter of fact. Right, you realize a couple of things here as a matter of fact. That here, this one is the cumulative frequency block. Right, so in the cumulative frequency block, where do you have 25 as the position? So you have 20 here. And the, all right, so you have 4, 1, 2, 3, 4, 5. So this is like steps of 4. Steps of 4. So that now, if you are to look for half 100, so it's going to be at approximately 25. So therefore, it's going to be 20 plus approximately a 4 and slightly higher than that. Slightly higher than that. So if it is slightly higher than that, what does it give us? Right, so it means that you'd have approximately just above here, just above there. Okay, just above there. Right, so let me just remove this one. That's fine. I want to make it quite straight, a little bit straight. So you have 24, just a little bit above there. So if it is like this, what will the vertical line be at the point of intersection of this? Right, so it is going to be at about here. Right, so now if this is 10, right, so if you move in steps of 10, for example, you look at this in steps of 10. So in steps of 10, this is like 5, then this is like 10. So this is 1, 2, 3, 4, 5. And then 6, 7, 8, 9, 10, 11, 12. So approximately this point is a point where you have 10, 11, 12. So you have 12 here, you have 12 there, and here you have what? You have approximately the position 25. The position 25. So it means, on average, you have that Q1 is the same as 12. You have that Q1 is the same as 12. And then let's look at Q2, for example. In the middle, 50% of the position. So now 50% of the position is, we said half of 100 and we got 50. So which means that if you have 40 here, and then you're going to add 4 more, 44, 48, and then 52, which is 40 here, 44, 48. And then after 48, you have 52, which means that this is going to be slightly here above this. It's going to be here. Hey, this is just estimated. You can use a different color here. And then here now you need to drop something. So which means then here you're going to have what? The position is going to be 50. Okay, and then we saw that here it was 25. So here it's going to be 50. But now it's going to be going down here at a position. This is steps of 1. So if you are just at 20, it's going to be at 19. So this is like 19. And then now you look for Q3. Q3 is going to be at position 75 of the 100. So 75 now it's going to be, you have 60, then you add 4, 64, 68, 72, 76. So below 76 is 75. Is 75. Okay? And then now you're going to drop something down. Okay. Let's see now. If this one is 20, 21, 22, 21, 22, 23, 24, 25, it appears as if this one is 25. Okay, approximately 25 here, approximately 25 here. So we have something like this, okay? So now, okay, so it means therefore that Q3 is going to be at approximately that position and it is at about 25. Okay, these are just approximate. Right, so now you have these. Now you have these. But these are the times in the minutes. In minutes there. There. Okay. I'm trying to get the box and whisker plots. Okay, the box and whisker plots now has the following things. Okay, because it has those characterizations. It has those tiles, Q1, Q2, and Q3. Okay. Right, so we continue. We continue. Right, so with that said, we move on. We certainly move on to look at more things. Now, the box and whisker plot that must be drawn has certain characterizations that are very, very important for us. Right, so we're going to have the minimum, and then we're going to have the maximum. Right, so let's do this first. You'll have to plot this box and whisker of these quartiles on this diagram. After having plotted these on the diagram, you shall be in a position to continue. We shall be in a position to what? To actually continue very much. Right, so let's just get moving here. Let's just get moving here. Okay, let's get moving. Let's get moving. Right. So we continue with our work. We continue with our work. Right, so the couple of things then that remain very, very important here. And they are the fact that you have okay, I want us to finish this calculation. So we're gonna finish this calculation just now. I want us to draw the box and whisker plot here and make sure that we're good. To draw the box and whisker plot here and make sure we're so good. So good. So now we continue with our box and whisker plot. We continue with our box and whisker plot. Righty. Right. Okay, so what do we get? What do we achieve out of this? Right, we're gonna just achieve just right now. Gonna just achieve right now and get what we desire. Okay, and get what we desire. I'm just looking at this now. I want to get what we need. Right, so now what do we need actually here? What do we need actually here? Right, okay, we are just going on. So take it very, very easy. We are doing our calculations and we are in a relaxed mode. I'm trying to make sure that we get all the answers we need. We get all the answers we need here. Right. Okay. And then now we're going to take note of the values we have. And we're going to plot the values from this diagram. We're going to plot everything on the box and whisker plot so that we are happy and we are very much understanding. We are very much understanding. Right. So I must indicate that there are formulas sometimes that can be used to do these calculations. Or I'm going to state these formulas that can be used to do these calculations. That slightly more accurate values of these can be determined and can be found. Right, slightly more accurate values can be found, for example. Right, so we shall actually be so good then in a minute. Right, so I'm going to give you other formulas that can be used to find the Qs. The Q1, Q2, and Q3 for grouped data. Okay, because obviously you can find the Q1, Q2, and Q3 for ungrouped data. But what do we do in the event of grouped data? Right, so these are the things we're getting. But note the formulas. Okay, we have a chance to practice. Okay, you can call them formulas or you can call them formulae. So we have an opportunity to explore these. Right, you can learn this and then you can um, teach your friends. And because now this is exactly the kind of thing you need. The kind of thing you need. Okay. Now I want to give you these formulas. Q1, Q2. There's a formula for Q1. Okay, we say Q1 is L plus, you might be seeing this for the first time, but it's going to help you in that metric. It's L plus N over 4 CF, you divide by 36, and you multiply by C. Okay, let me use different colors because it's going to be boring, same color. The formula for finding Q2. The formula for finding Q2 is going to be L plus 2n over 4 minus CF divided by the frequency in here. Let me put the frequency here. Okay, divided by the frequency, and even here divide by the frequency. I want to give you the general formulae so that you learn them. And then you multiply these by the C value. What about Q3? The formula for Q3 for grouped data is L plus 3/4 of n minus CF. You divide everything by the frequency. You multiply by C. All right, so now you say here the L stands for the lower boundary point. Lower boundary point. Right, so you first find the position. So for Q1, like we found the position. For Q1, we said we're 25. And then position 25. Right, so now at position 25 for Q1, what class did that give us? The 25th value of the observation in the cumulative frequency column. Okay, because now generally you'd have to find the cumulative frequency column. Okay, just allow me to just say a little bit more about this. We have a chance to explore this. You might have never learned this at school. So cumulative frequency now is going to start from 20. You have learned cumulative frequency, I know. And then you add 36, you get 56. And then you add 36, you get 88. And then you add 8, you get 96. And then you add 4, you get 100. Okay, this is the total. So this is the cumulative frequency column. Okay, with that being said, we're able to continue. We're able to continue and say, Q1 is at position 25. And now, and the value of the observation, the value of the 25th observation in the cumulative frequency column, and it lies in the what? The 25th position. 25th in the cumulative frequency lies between 10 and 20. Just teaching you another method here of finding these without drawing the lines there, without this table, right? Without this graph, this Ogive. Okay, so now you say it lies between 10 and 20. And if it lies between 10 and 20, then what is the lower class boundary of 10 to 20? The lower class boundary is what? Is 10. Okay, so that would therefore mean, using this formulae, we're just practicing now. Okay, this formula, this one, you will watch the video, it will help you even when you go to university. So this one now, I'm going to use the formula straight from the top. So which means the lower class boundary of this is going to be that. The lower class boundary of the 10 to 20 is 10. Plus the n over 4, which is now 100 over 4. What is 100 over 4? Is 25. The cumulative frequency value there. What is the cumulative frequency value there? Okay, so right. What is the cumulative frequency value there? Right, in the preceding class. Right, and the lower boundary point. Right, what is the lower boundary point? What is the lower boundary point? Right, so what is the frequency straight away there for the denominator? The frequency straight away is 36. And then here, this one would be at exactly 20 would be the cumulative frequency. What is the cumulative frequency? Right, so the cumulative frequency of the preceding class, the cumulative frequency of the preceding class, okay, or the cumulative frequency, yes, of the preceding class, what is it? Okay, so it is 20. You multiply by C, and C here is the lower boundary point of the 10 to 20 interval, and this lower boundary point is what? The lower boundary point is 10 still. Okay, I'm just showing this here. So this is 10 plus. Just another method of finding Q1. So it is 10 plus 25 minus 20. You divide everything by 36 times 10. It is Q1 is equal to 10 plus 5 over 36 by 10. Q1. It is 10 plus 1.3889 Q1. 11.3889. Okay, you see, we got 12 for Q1. So I'm just having this debate. We got 12 for Q1, but approximately 12. So, but a more accurate value is this one, which is 11.3889. So in the marking center of the matric exams and the grade 11 exams, this is always taken into account, that there are discrepancies, and we always give the estimate. That is why here I was saying approximately. So with this spirit, I'm going to do Q2 and Q3 using the formulas I've just given here. Okay, so now let's look at the formula for Q2. So the formulas just differ by Q1 would have n over 4. Q2 has 2, n over 4. And Q3 has 3. Q2 would have this. So it's L plus. Q2 would have this. 2n over 4. 2n over 4 minus CF. Minus CF. Okay, 2n over 4 minus CF, and then it is divided by the frequency times the lower class boundary point, Q2. Now, we did Q2. Let's look at the position. We said it is at approximately 50, this Q2. Right, at approximately 50, it means that the kind of class we're talking about is which class for Q2? Right, so at 50 position, right, so if the position is 50, it is approximately where? Right, so we're looking at the cumulative frequency. So which means that we are dealing with, at 50, we are dealing with 10 to 20. We're dealing with 10 to what? To 20. And the lower boundary point, just write down some data here. Let me make it red. Something called the lower boundary point. Okay, the lower boundary point is L, 10. 10 from 10 to 20. The frequency is 36 for 10 to 20. You can see it here. And then the 50th value of the observation in the CF column. The preceding value is what? Is 20 in the cumulative frequency. And then the lower boundary point for the class from 10 to 20 is what? The lower is 10, the lower boundary point. So which means Q2 is L, which is 10 plus 2 over 4 into N, 100. CF. C is exactly is 20. CF. The preceding one is 20. And then we divide everything by the frequency is 36. We multiply by 10. Okay, these formulas, you might have never seen them, but yeah, just take note of them and learn them. They really give you very, very accurate readings there of the um, grouped data calculations. Right, let's look at Q2. Okay, your teacher might have not taught you these, but yeah, they are very, very powerful. These are like bulldozer formulae. So this Q2 then is 10 here plus. Okay, so this one is 50 minus 20, and you divide by 36 times 10. And then this is Q2 equals 10 plus 30 out of 36 times 10. Q2 is 10 plus 30 out of 36 by 10 is 8.333. 4 decimal places. Q2 is going to be 18.333. Okay, we got an estimate of that of Q2. How did you get Q2 to be estimated? We estimated Q2 at about 19. But a more accurate reading, obviously, is 18.33. Okay, we're looking at the statistical analysis here. So this is all rich information, rich statistics. So now we're going to look at Q3. So I'm just going to do Q3 quite quickly there. Okay. So you have this. Okay, so you continue. So Q3 is done in the same way. What is the formula for Q3? Right. So Q3 therefore is L plus 3n over 4 minus CF, the preceding frequency in the cumulative frequency column, and then frequency times the lower boundary point. So let's just do this one quite quickly. So now we said that Q3 is, what is the position of Q3? Right, let's just check the position. We did it together. What is the position? Okay, it's 25. Q3 is position, oh no, it's position 75. Position 75. So position 75, frequency-wise. So if you're position 75, frequency-wise, where is 75? Right. 75 is cumulative frequency-wise is somewhere there. 20 to 30. 20 to 30 class. So it means that all right. Okay, we'll continue. Right, so what is the lower class boundary? What is the lower class boundary point? L. Lower class boundary point. So here you can say lower class boundary point. Okay, you need to write these things in your book. Okay. Right, so what is the lower class boundary point? Right, so the lower class boundary point is gonna be exactly for the class 20 to 30. The lower class boundary point, now we call that L. L is 20. And now this one now of the preceding class in this is going to be 56 there. And then the lower class boundary here, boundary point is 20. And then now okay, let's look at this very carefully. Okay, so the C is going to become right. So L is that, and therefore the frequency is what? For the class 20 to 30 is 32. Okay. And then now we have the 20 to 30. Right. The 20 to 30 right. So that one is exactly your class width 10. Your class. So which means Q3 so L is going to be 20 plus 3/4 N is going to be what? 100. CF 56. We continue. We continue, please. Apologies for that. Can you still hear me, Nobile?
Yes.
All right, thank you. My apologies. Okay, I received a call on my system, so now I can hear that it's just affecting my what? My I thought maybe it affected my ability to. Right, so it's 100 here minus 56 divided by what is the frequency here? I said it's 32. The class is of the width 10. So Q3 is exactly 20 plus 75 minus 56. You divide it by 32. Okay, we're just learning statistics here. Q3, 20. 19 over 32 times 10. Q3, which is 20 plus 5,93. Can put the decimal point here. Like 5.93, then 75. I know that this you might have never seen in your whole life. So this one is 25.9375. Right, so that's something you need to note. Okay, something you need to note. Note that. Right, so what we're doing here is something called the 5-number summary as well. Okay, you'd remember that the Q3 was found to be what? Q3? Okay, we used a ruler to do the measurements at about 25. We estimated it at about to be at a position 75, but 25. So Q3 was about 25, and here is a more accurate value. We can be able to get the accurate calculations. Okay, it's 25.93 will be a more accurate result, value of Q3. Okay, so we have that. Now, we need to construct the box and whisker plot using the diagram sheet, but I want to mention that in view of what to call the 5-number summary, 5-number summary, 5-number summary. Right, so the 5-number summary. But before I state the 5-number summary, I want to speak about something called the class length. And the meanings of the symbols. of the symbols in the formulae. Right, so please stay tuned because we are enjoying ourselves with statistics today. Became a topic of choice from you. The next topic is we shall see functions and other things. Right, so C in these formulas becomes the class length. For example. Right, so the L stands for the lower boundary point. The lower boundary point. Okay, so the L stands for the lower boundary point of the relevant class. And then now you have N, which is the total frequency. Which is the total frequency. And then what is CF? CF is the cumulative. Is the cumulative is the cumulative frequency of the class preceding the relevant class. And then this one becomes F becomes the frequency of the relevant class. The relevant class is the class associated with the position of the relevant class. And then C is the class length. Obviously, by class length of the relevant class. Class length of the relevant class. So with these, you're able to see that Q3, for instance, and the other formulas would be, and the other things would be given by what we just said. Okay, Q3 will be given by, all right, so will be given by L plus 3n over 4 minus CF. We divide everything by F times C. That would be the Q3, and we stated that above. Okay, so I wouldn't want to repeat that one, otherwise I'll just be wasting time. But I want to also speak about something we call sometimes you might need to find the median. What is the formula for the median? Okay, your teacher might have not given you this, but you can learn this and surprise your teacher when the question comes. So the median is normally, you can call it M. It is L, where this is the lower class boundary point. Plus now you put N over 2 minus CF minus CF. You divide these by F times C. Okay, obviously this one, you can see that this median is actually equal to what? Is actually equal to Q2 because it is in the middle. It is the same formula as Q2 there. So note the formula for the median. But also you must know how to calculate the mode. What is the mode? Right, so the mode is a little bit complicated, but yeah, let's speak about how we can calculate the mode. Because you can find the mean. We spoke about the mean before. The mean, what is the formula for the mean for grouped data? So for grouped data, the mean is Fi xi divided by, can say sum of Fi here. In which case it is the sum of Fi xi you divide by n. So that is the sum of this. So now we continue with this. Okay, we use the formula for the mean, so we are good with that one. But okay, I'm just moving to the 5-number summary. All right, I know that I've kept you here for a while now, but I want to speak about how to calculate the mode. What is the formula for the mode? And to find the modal class or the mode class. Right, so the formula for the mode is not very popular in the school curriculum, but today we have a chance to learn how to calculate the mode. And also what the formula for the mode is. So the formula for the mode is, normally the formula, the mode can be called Z, which is L plus F1 minus F0 divided by 2 times F1 minus F0 minus F2. You multiply by our usual C for the length of the mode class. Okay, so this is the formula for the mode. This is how we found the mode. But L stands for the lower boundary point. Boundary point of mode class. Okay, so I'm just gonna find the mode here in this one, in this question. What is the mode here? So I'm gonna just find the mode here using this formula. Okay, they did not ask us, but we are practicing today. Okay, right. So, but you must know also how to find F1 for the mode. The frequency of the mode class. Okay, obviously we're going to discuss the mode class. The mode class is the class with the highest frequency. So at this point, if you look at this, you'll realize that the one with the highest frequency is 36. The highest frequency is 36, and obviously that is going to be your mode class or your modal class. So F1 is the frequency of the mode class. Frequency of the mode class. What is the frequency of the mode class? Is 36. Okay, is the highest frequency in the table. And then now we have F2, rather F naught. F naught. F naught is the frequency of the preceding class. Frequency of the preceding class. So, for instance, what is the lower class boundary point of the mode class in our question? The lower class boundary point of the mode class is what? Is 10 here. And then F1 is the frequency of the mode class, and it is 36, the frequency there. And then F naught, the frequency of the preceding class, and the frequency of the preceding class is what? Is 20. Is this one there. F2, the frequency of the succeeding class. Frequency of the succeeding class. The frequency of the succeeding class is exactly 32. So now C stands for the class length. The class length of the mode class. The class length of the mode class. Which is 10. Okay, we continue. So Z. So the mode, you can call it Z. Is L plus F1 minus F naught. Double F1 double F1 minus F naught minus F2. This is how we find the mode. The teacher might have not taught you this formula for the mode for grouped data. So we saw that L is 10 here, plus F1 is 36, minus F naught is 20, which is 2 times F1 is 36. F naught is what? F naught is 20. F2 is 32. You multiply these by the class width or the class length. So this then is 10 plus 16 out of 20. Z equals 10 plus 8. And this is 18. Right, so it therefore means that the mode is 18 and it occurs in the class that has the highest frequency. So the mode is 18. Just note that. The mode is 18. Right, so we are going on. Okay, I digressed much. So Please forgive me for digressing and looking at other things. But I want us to now answer this question. Construct a box and whisker plot. So we're going to look at the actual answer to 1.2.1. But 1.2.1, we say when you answer it, thus the 5-number summary. 5-number summary. Right, so the 5-number summary is what? Okay, you can just include some numbering here so that you can see you're dealing with 5 numbers. Right, so the minimum value equals what? And then 2 is the first quartile. 3, the median, is also called Q2. 4, we saw the formula for the median for grouped data. The third quartile, Q3. And then here we're going to have the maximum value. Okay, this is called the 5-number summary. Show you a way of this one. For the data sets we are dealing with here and in view of this Ogive, the minimum value that we have, is 0. The first quartile, we've already seen that is 11.3889, approximately 12, we said. Q2, which is the median value in the middle, is 18.3333, and we said it's approximately 19 in terms of what we got from the Ogive. Okay, right. But we calculated the accurate values for your question. Right, in the third quartile, Q3, right, I know that I've taken so much time. Maybe you need to have your dinner as well. You need to have your dinner. So it's 25.9375. So obviously this one I quoted it about approximately 25, but yeah, in terms of what we got there. The maximum value. The maximum value here is 50. So let's just draw the box and whisker plot for this one. So we're going to draw a horizontal axis like this. And then we're going to draw the box. Oops. Then we're going to draw the box. Then you're going to have this. Then you're going to have a whisker here. So this one here is going to be the minimum. And this one is going to be the maximum. And this one is going to be, the maximum is 50, but the minimum is at 0. Here we're going to have Q1, Q2, Q3, 11 point, 889. This one is 18.3333. And this one is 25.9375. 0. 510. 15. 20. 25. 30. 35. 40. 45. 50. Okay, let's look at. Okay, they gave this one. Okay, but yeah, you'd have this box and whisker plot. You can just extend these to, yeah, okay, but the 0 is enough. -5, yeah, it's outside. It's okay. So this is what you have. This is what you have. So what do you think about this data? And we analyze it together in terms of the skewness of the data. In terms of the skewness of the data. Right, skewness of the data. For example, what would, construct a box and whisker plot, scaled axis, and summarize the data, show the Ogive by means of dotted lines. Can use some dotted lines there, etc. Where you have read of the data required for the box and whisker, use the diagram provided in the diagram sheet. All right, in 1.2.2, is the data positively or negatively skewed? And we need to provide the answers, so we are analyzing that one. Right, we're analyzing that one. Let's analyze it together. Right, so now let's analyze this. So in the positive skewness, I want to say something here. So you'd have to say, Q3 minus Q2, and then compare to Q2 minus Q1. Let's do this. What is Q3? Q3 is 25.9375 minus Q2, which is 18.3333. What is Q2? It is 18.3333 minus Q1, which is 11.3889. So let's see what is happening here. What is the difference? What are we getting here? Let's use our calculators. Okay. So this is going to be 25.9375. 25.9375 minus 18.12, that. 5.9375 minus 18 point that. So we're getting here 7.6042. Now here we also have 18.1234 minus 11.3889. 6.9444. So in view of this difference, you're able to see, therefore, that this one is bigger. Use a red color. You're able to see that. So now we are doing which question? We're doing 1.2.2. We're able to see that this is bigger like this. Right, so we're able to see that Q3 minus Q2 is bigger than Q2 minus Q1. Right, and so the minute you can see that Q3 minus Q2 is bigger than Q2 minus Q1. Well, what it means is that the box and whisker plot obviously is not drawn to scale in the diagram we drew together, but it means that if Q3 minus Q2 is bigger, it means you have something like this. So here you have Q3 minus Q2, and here you have Q2 minus Q1. So this means that it is positive. It is positively skewed. Okay, you can say it is positively skewed. If it is positively skewed, what else do you say for the positive skewness? If you don't want to use the word positively skewed, you say it is right skewed. Right skewed. Can you say it's right skewed or positively skewed? Otherwise, it's negatively skewed. Okay, is the data positively skewed or negatively skewed? It is positively skewed. Why? This is the reason. The reason is that Q3 minus Q2 is bigger than Q2 minus Q1. And therefore, it is right skewed or it is positively skewed. Okay, I want to speak about skewness of data. We can also have data that's like this. Okay, you can have data that's like this, and then now you have this sitting here. Data that's like this is said to be negative. Negatively skewed. Okay, it is negatively skewed, or you use the word left skewed. Now, this skewness but also you can say this. Now, negative skewness means that Q3 minus Q2 is smaller than Q2 minus Q1. Q1, Q2, Q3. So you can see that Q3 minus Q2 is smaller. Okay, so this gap is very small. Okay. And therefore, it is said to be negatively skewed. If you don't want to use the word negatively skewed, you use the word it is left skewed. It is left skewed. What about if it is not skewed at all? It is not skewed at all. So there are times when you have a normal distribution of data. So now you might have no skew. No skew when this is in the middle. And there's Q1, there's Q2, there's Q3. So if this is true, so at this point, no skew. Okay, I'm going to release you so that you can relax and prepare for tomorrow. You're going to school. But I will say to you, when it comes to no skew is something we call the normal distribution in statistics. Normal distribution. Normal distribution. Normal distribution. Normal distribution. But it means that Q3 minus Q2 is equal to Q2 minus Q1. So if this Q2 is in the middle, is in the center, so Q3 minus Q2 becomes Q2 minus Q1, and then we have what? Normal distribution. Normal distribution. This one we've already done. This question we've already done. I think that is some good time for us to stop and call it a very good evening, right? Okay. Any question? No question. You are tired. Are you tired?
Yes.
All right, that's fine. Was this a homework? These questions, were they homework or what? A test?
Yes.
Which one? A test or a homework?
It was a test.
Okay, that's fine. Right. So, yeah. So we can continue tomorrow. If you are free, you let me know. Okay.
Okay.
I'll do more of these kinds of questions tomorrow. All right.
Okay.
And the last little bit of question that's left, but now we've gone just beyond 2 hours, so I think that you need to rest. You know, it's not fair to you. But thanks a lot and have a good evening. I will send the video in like more than 30 minutes. It takes 30 minutes for Zoom to send the video to me. After Zoom has sent the video to me, then I need to upload the video on YouTube. So yeah, it's about 1 hour approximate time that I can send the video to you, the link to the video. Okay, but I'm gonna send it because I was recording the discussion. All right.
Okay.
Thank you and have a good evening, Nobile.
Thank you.
Goodbye, goodbye. Okay, your practice is one. How do you practice? Your practice is you need to write the notes. When I send the video, then you during your own spare time, you write the notes, you write down the questions and the answers, question, answer, and look at the steps, and then close the answers and see if you can be able to solve the questions without looking at the answers. Then if you're able to do that, then it means you have learned. But tomorrow I'm going to give you additional exercises. Okay. All right. Thanks and have a good evening.